All right, here we go. So 4.4c, this is still GCF and Star Factoring.
Can I go to the restroom?
Why do you wait until I start the lesson for that?
Okay, I'll wait. It's pretty far.
I mean, if you're going to pee your pants, go. But I'd rather you be here.
I can wait.
Okay. GCF and Star Factoring. Here we go. So these are problems that you can do with the STAR method. They often end up being big STAR method problems, so they're kind of a pain in the butt, but it can be done. You can, just if you want to like go sit over there or you want to go sit over there and do it, that's fine. So we're going to give you, that desk is terrible though. You might want to pull your desk over. It's got a real loose thing on it. I'm going to show you a couple shortcuts that you can do, a couple they're just shortcuts. Just make sure when you're doing these types of problems that you're still looking for the GCF and then you factor it completely, okay? I just want you to see how this works. So I'm going to give you this first example using the STAR method to show you that, yes, you can still do this with STAR, but I'm going to give you the shortcut. So here is your STAR method for this one. What would go on top here? 16. What goes on bottom? Okay, and then your A term is 1 and 1. So you're asking yourself, what can I multiply to get 16 that I can add to get 8? What would that be? 4 and 4. Okay, so here's the deal. This is a 4, this is a 4. Now look at your two fractions, if you will. They're not actually a fraction, but you end up with x plus 4 times x plus 4. The better way to write that is x plus 4 squared. When they're identical like that, it's x plus 4 squared. And that's how I want your answer. I want you to square it like that because we want the simplest form, okay? So now what I want you to see is you could have taken a shortcut on this problem using, these are called perfect square trinomials. So if you have this setup where it's a number squared plus 2 times that number square rooted and the other number square rooted, and then your last number is a perfect square, so b squared. What happens is if you're adding right here, it's this setup every time, which means it's a plus b squared. If you're subtracting right here, it's this setup. You're subtracting in both your binomials, the exact same things. So it's this a minus b squared every time. Okay, so what you're looking for a lot today are perfect squares. So let me show you in this first problem here. When we factor a perfect square trinomial, basically you are going to square root both first and last. Okay, so look here and look here. If those two numbers are perfect squares, there's a good chance you can do the shortcut. It's not a guarantee, but it's a good chance, okay? So here's what you do. You look at those two numbers and you think, okay, if I square root this, what do I get? What's the square root of 49x squared? 7x. Okay, then you look here. If I square root 9, what do I get?
3.
A 3. Am I gonna add or subtract in this problem? We're gonna add because of this symbol right here. Okay, this should be addition, and we square it. But now you have to check something, okay? The way you check it is that your 2ab is actually what it was supposed to be. So you're gonna look, let me get this out of here so we can see that number. You're gonna look here, 42x. That should be 2 times your a, 7x, times your b, 3. So 2 times 7 is 14. 14 times 3 is 42 times x. This is the same as that, so we know that this is the right setup. Okay, it's always got to be 2ab, just like we had in that starting setup up top. Does that make sense? So if you can double the product of your two terms and it works out to that b value, you're in good shape. Okay, so look at letter B here. You see a perfect square here and a perfect square here. So we think, do what? How do you start? Square root both of them. So I'm going to square root 25x and I'm going to square root 4. What do I get for 25x squared, square rooted?
5x plus 2.
5x, okay. Square root of 4 is 2. Are we adding? We're subtracting. It's always the first symbol you see. So there will be 2. There will be a minus and a plus, or there will be a plus and a plus. Whatever that first symbol is the symbol that's going to go here. Okay, so that's minus, and then we square it. Now check it. Is 2 times 5x times 2, or negative 2, equal to a negative 20x? Well, 10 times a negative 2 is negative 20 times x. It works out to that same value. So that's how we know that that is our answer. Okay, so this is just us checking our answer. 9 times out of 10, it works out. So, okay, this one's a little bit tricky because 100x squared and 4 are perfect squares. But do you see something else that we can do first?
Divide by 4.
Divide by 4, right? You can factor out a GCF, so don't forget, maybe make a note, GCF first, because if you don't do the GCF, you end up with funky answers that eventually you could simplify, but you might not notice to simplify. So take the GCF out first. So if we take a GCF out, if we divide by 4, we'd be left with 25x squared minus 10x plus 1. Okay, and now we still have perfect squares. So our answer, and I would write this down right away if I were you, is going to look something like that, right? We don't want to forget about our friend the 4 out in front. Are we going to be adding or subtracting?
Subtracting.
We're going to be subtracting, so we know this is a minus. What goes in this first gap?
5x.
5x. We're going to square root the 25x squared, so that's 5x. We're going to square root the 1, which is 1. So we get, oh, yes, this as our answer. Now check it, okay? But you have to check it against your new setup. You have to check it against this one because those are the numbers we're working with here. So 2 times 5x times negative 1 should equal that negative 10x, and it does, so we know that it worked. Questions on that? You good, Jonah?
Yeah, I was just wondering how you got the negative 1. I got it now.
Good. This
Yeah.
symbol is always, that first plus or minus symbol is always what's going to stay with your setup there. All right. Why don't you try letter D? GCF first, right?
I was confused how you got the 5x.
So we're taking the square root of, I can't really see that. The square root of that first term. So 25x squared. If I square root 25x squared, the square root of 25 is 5. The square root of x squared is x.
Oh, okay.
That makes sense?
Thank you.
You're welcome. All right, try letter D. See how you do there. Did anyone find the GCF yet?
Yes.
What is it?
4. 2.
It's 2. Yeah. So when you're doing your GCF, it's 2. How many of you have an answer right now? Handful of you? Okay, I'll give you another minute or so. 30 seconds maybe. Okay, so when you factor out the GCF, it should look like that. Hopefully you got that. I would right away write it like this. Is there going to be a plus or a minus in there? A plus because of this guy right here. What did you get as your first term when you square root? 2y, right? The square root of 4y squared is 2y. What'd you get as your last term? The square root of 49 is 7. So then double check it. It should be 2 times 2y times 7. So 4 times 7 is 28y. And look up here, that's a 28y. So it checks out. So this is your answer. Did you get that? Hopefully, yes. You're confused?
Yeah, like, I got like the same, like, what are you doing? Right?
You're square rooting. You're going to square root your first value and your last value. So we started with this, right? 2 times 4y squared plus 28y plus 49. So when you have that set up and you notice that this is a perfect square and this is a perfect square, then we take the square root of them. So you're going to square root 4y squared and you get 2y, and you're going to square root the last value. So you don't do anything with the middle value. That's just how we check our answer. Square root that last value, and you get 7, and then this symbol is what goes here. So square root, put the 2 out in front, square it, and keep the symbol of your first symbol in your setup.
Is it 2 because 2 can go into all 3 of them?
This is 2 because we factored the GCF out first, right? So it started like this, 8y squared, 56y, and 98. You can divide all of that by 2. So factor out the 2 and then work with what you're left with, okay? Any questions on that? Those are called perfect square trinomials. So if it says factor the perfect square trinomial, you know this is what you're doing, okay? The other shortcut that we're going to do, I think, is the easier one. You might disagree. Well, I don't know. I guess not easier. I don't know. That's for you to judge. But this is called a difference of squares. Okay, so you will have 2 perfect squares. And the difference, what is a difference? Subtraction, right? So when you are subtracting perfect squares, that's when we use this. Notice on all of these, there is no b term anymore. Okay, so when you see 2 perfect squares subtracted with no b term involved, chances are you're using this method. Okay, and here it is. It says, well, let's just do it with this first. Here's how you can set this up. If you don't want to use the shortcut, this is what you'll do. Okay, if we're going to use star method here. So notice those are both perfect squares. I can take the square root of x squared and I can take the square root of 144. Without using the shortcut, this is what you would do. This is your c term. So a times c right now is a negative 144. Okay, what can you, sorry, before I go there, what's your b term right now? 0. Okay, so you have to put a 0 in here, which is where I think people get confused if they try to set up the star. But you can, it will work every time. So our a term is 1 and 1, and we're asking ourselves, what can I multiply to get a negative 144 that when I add, I'll get 0? What is that?
12 and negative 12.
12 and negative 12. Okay, so notice what happens. I get x plus 12 times x minus 12. Okay, so this is actually our answer for that difference of squares. Do you see what's happening? You take the square root of both, just like we did before, but now one of them is going to be plus and one of them is going to be minus. Okay, so when it looks like this, a squared minus b squared, You take the A and B values, you add them together, and you subtract them, and you have your two binomials, and you're done. Okay? So look at this letter A. Letter A here, this is a perfect square, and this is a perfect square. So what we're going to do is we're going to square root the left, and we get what? 2x, okay? Square root the right, and we get what? 5, okay? So those are the numbers you're going to use, but now you get two binomials. One is going to be plus, the other one's going to be minus, and that is your answer. Okay, so you can't write it as something squared anymore because they're always opposites of each other. One's adding, one's subtracting. So just remember, when you have a perfect square, a difference of squares, when you have just the two numbers, you should have two binomials. When you have all three of the numbers, you should only have one binomial and square it. Okay? Matthew, did you have a question?
No.
Okay. Okay, so letter B, what do we get here?
5x minus 10.
And,
5x plus 10.
yes, 5x minus 10 and 5x plus 10. And it doesn't matter which one you put first, the plus or the minus, but we square root this and we square root this. So 5x here, 10 here, one of them gets added, one of them gets subtracted, and that's your answer. That feels easier, right? Or is that just me? I think that feels easier than the trinomial. Okay, letter C, you do that one. What do you get for letter C? It's a little bit trickier, but not a lot. I believe in you. What do you get?
2x minus 11y and 2x plus 11y.
You like to put the minus first. I like to put the plus first. 2x plus 11y or 2x minus 11y. And then the other one, 2x minus 11y or 2x plus 11y. So one of each, right? Just make sure you pay attention to the fact that they put a variable in that second term, which doesn't happen often, but it does happen from time to time. Make sure you're using that variable when you square root. Okay. Okay, letter D. This one's a little tough. And we'll see if you pick up on it. Actually, try it. You try it. See if you see what you need to see when you solve this one. Give it a go. See what you get. And if you want, you can move on to letter E as well. That's our last one.
The 2y squared, but, or no. I think I did something wrong.
2y minus 9, 2y plus 9.
No. You guys are all very, like, on the right path. What'd you get, Kate?
Y squared plus 9 times y squared minus
No. What'd you get?
y minus 3, y plus 3.
No. You guys are all like right there. What'd you get, Sam?
4y plus 9 and 4y minus 9.
No.
Is it y to the power of 3 plus 9 times y to the power of 3 minus 9?
No. I love that you guys are working on it though. Okay, so think about difference of squares, right? These are both perfect squares. If I square root and square root, I get y squared plus 9 times y squared minus 9, right?
You got it.
It's like two different.
Okay. I know. That's not the answer.
Oh,
I know.
because you still have squares.
That's not the answer.
So just my.
There's still a difference of squares. Do you see it?
Yeah.
This is actually y plus 3 times y minus 3, right? So this we can't simplify. It's not, there is no sum of squares simplification. We can't do anything with the y squared plus 9. So that has to be y squared plus 9 times y plus 3 times y minus 3. Tricky, right?
Are we gonna get questions like this on the test?
Maybe for a
Potentially. What?
bonus. I said for a bonus. Could be
For a bonus? Maybe for a bonus. Questions on that? Okay, so thinking about that, what do we do with this?
X plus 10 squared.
Wait, wait,
Not x plus 10 squared. What do you do first on this problem?
the question on the last one, why is there a squared on the y?
On the y
Oh,
here?
the final answer, yeah, y.
Because we squared rooted the y squared, or y to the fourth, right, is y squared. But this can't be simplified at all. It's not a difference of squares, right? If you think about like, oh, what could I do here? A lot of times people are like, well, why can't you do y plus 3 times y plus 3? But think about what that would be. This would be y squared plus 3y plus 3y. So plus 6y equals, or plus 9, not equals 9. So this is not that. A lot of times people try to make it that, right? But you can't. It's not the same thing. So when you have that set up, you're just done at that point. Sorry. Okay, so that applies right here. What do we do first? Factor out the 5. So we're going to take out a 5 and we get x squared plus 100. Okay, now this is what we just talked about. You have x squared plus something. They're both perfect squares, but we cannot take the square root and add them together, because if I did that, x plus 10 squared is x plus 10 times x plus 10. That's x squared plus 10x plus 10x plus 100. That, not 1100, just 100. That's x squared plus 20x plus 100. This is not that, right? They're not the same thing. So you cannot do that. So your answer on this one is actually just what we have there. 5 times x squared plus 100 cannot be simplified at all. So pay attention to your symbol. If it's a subtraction, that's when we can do difference of squares and do one is plus and one is minus. But when it's addition in there, you can't do that. Okay? Any questions on that?
So addition is hard to simplify for that type of
Yeah, so maybe just make a note. You can't factor a sum. Okay? You can only factor a difference of two squares. You can't factor a sum of two squares. Two perfect squares. Okay? Questions on that? So it's a bunch of shortcuts today. Use the shortcut as you'd like.